Hey everybody, here we are back talking about the Appley homework for micro competitive markets. It's chapter 13 or 14, I can't remember which right now. So I want to talk a little bit about what these curves mean. So right now we're looking at the graph for a competitive firm, a firm in competitive markets that's making cardboard boxes. So the demand curve, this is market demand and market supply. So it doesn't matter how many boxes this firm produces, they're going to face an equilibrium price of, moving things around, an equilibrium price of $10. So this firm can produce 5 million boxes, they can produce 2 million boxes, they can produce 10 million boxes, it doesn't matter what they do. They're a small enough part of this market that their price is always going to be $10. So if they produce one box, their total revenue will be $10. So total revenue is price times quantity. So this is not profit, this is revenue. This is how much they earn whenever they sell a box, they get $10. One box $10, 2 boxes $20, 3 boxes $30, and so on. So this question asks you to do things like find average revenue and marginal revenue. So total revenue again is just price times quantity. So total revenue, price times quantity. So $10, $20, $30. That means your marginal revenue is always going to be $10 because every time you sell another box, you earn another $10. So marginal revenue is just $10. So in this one, when we went from 1 to 2, our total revenue went from 0 to 10, marginal revenue is $10. When we went from 1 to 2, total revenue went from $10 to $20, the difference again, $10. Average revenue is just total revenue divided by quantity. So again, in this case, it will always be $10. So this is the rule for a perfectly competitive firm. It'll always be $10. The next question wants you to look at profit maximization. So we just looked at the revenue side. Now what we want to do to maximize profit is compare our revenues to the cost side. Remember the formula that we're looking for. We always produce, or marginal revenue equals marginal cost. Or in the case of perfect competition, that can be written where price equals marginal cost. So in this question, we're going to spend a little bit of time thinking about how that happens and why that's true. So the first thing they want you to do here for this question is plot total revenue and eventually profit here. So total revenue is pretty easy, right? It's just price times quantity. Okay, the other thing they had us produce here was profit. So profit is total revenue minus total costs. So profit, total revenue minus total cost. So when you're doing these questions, just think fairly straightforward. These are fairly straightforward math questions. Okay, so profit tends to go up and then it goes down. Why is that? That's because marginal cost goes up. So we always produce, again, we have to watch our marginal cost and marginal revenues. So what that means is that if the extra cost of producing one more teddy bear exceeds the extra revenue from selling one more teddy bear, then profit's going to go up. If the extra cost associated with selling one more teddy bear is less than what the money that you received from selling that teddy bear, then your total profit is going down because your revenues actually went down. They didn't go up at that. Well, your revenues went up, but your profit goes down, so your total profit goes down. So in this particular example, our marginal cost curve is here. Our marginal revenue curve, remember, is always exactly the same. It's $10 no matter how much we produce, because we're a very small firm in the world of teddy bear production. So we'd want to go ahead and produce this fourth teddy bear because we get $20 from it. It only costs us $15, so we come out $5 ahead. We wouldn't want to produce the fifth one because it costs us $25 to produce it. We only get $20, so we would actually lose money if we produce that fifth one. So we're always going to produce right here where marginal cost equals marginal revenue. You move to the closest point of production nearest to that. So if we did the problem, Amy's profit is maximized when she produces 4 teddy bears. Her profits go down after that because her costs exceed her revenues after that. So the last teddy bear costs $15, which is less than, I don't know what I was thinking when I put greater than, less than the price that she receives for each teddy bear she resells, which is $20. Okay? So let's add a couple curves to our cost diagram here. So here we've got a graph with average total cost up here. It's our standard marginal cost curve, right? It goes down, then marginal costs tend to go up. Average variable cost down here, average total cost up here. What's the difference between average total cost and average variable cost? So why is there a space between those two? There's a space between them because this space is average fixed cost. So fixed costs are costs that you can't change in the short run. So in the long run, all of your costs are variable, because in the long run you can get out of whatever long-term contracts you have. But in the short run, you've got some fixed costs. So you've got some debt that you have to service. You've got a building that you own and that you have to sell. You've got equipment that you own and that you would have to sell. So in the long run, you can get rid of all that. But in the short run, you can't. So in the short run, you've got some fixed costs. The difference between average total cost and average variable cost is average fixed cost. So average total cost is average variable cost plus average fixed cost. And on the graph, it's the space in here between the two. Okay, so in the short run, when you're thinking about production, you are willing to produce as long as you cover some of your average variable costs. And that's because as soon as you cover your average variable costs, what that really means is that you're covering all of your fixed costs. So you wouldn't, or at least some of your fixed costs, sorry. So you would not want to shut down because you're coming out ahead. You're losing money. So if we were producing, for example, if the price were 20, right there, we would go ahead and produce 9, and that's because we cover all of our average variable costs of production. You can see we're above the average variable cost curve here. And we're covering some of our fixed costs. So we're losing money here. And in the long run, we'll go out of business. But in the short run, we want to go ahead and stay in business because in the short run, we're covering some of our fixed costs and all of our variable costs. In the long run, we're not going to stay in business unless we're above this point. Because above that point, where our price is, about $27.50, we are covering all of our costs. We just got to our average total cost curve. And any price above that, this one say, we're very happy because there we're making some profit. So in this case, this distance right there is going to be profit on each of our items that we're producing. So I hope that makes sense to everybody how that works on the graph right there. I want to see all of your faces going up and down, and I can't do that from here. So the question actually asks you to figure out average variable cost, and to do that, you look at how much you're producing, the average variable cost, which you read off the graph, multiply those two together, and you get total variable cost. Then total cost is your variable cost plus your fixed cost. I want to pause here and let you think about these, and then I'll go back and look at some of the other problems in this particular chapter.